Welcome to the second and final video of this series, where we use the model feedback to label our undefined samples and add them to the training pool efficiently. How to strategize this and what to do next is what we're going to look at very carefully. Let's go to our run that we've created from our last video and open it up. Now let's go ahead and create firstly a 2D chart by control and clicking the image column along with the predicted label column, and then right click, create a 2D chart, or just do it by pressing 2 on your keyboard. And notice this embeddings column that we did not talk about in the last video. Let's go ahead and create a 3D chart from it. And there it is. All these data points floating in 3D space. Now here's what you're looking at. Every point is one training image, and the model places images it thinks are similar next to each other. Now watch what happens when I color this by predicted label. For that, just select on the predicted label column and then drag it and place it here. Now you can see what our model thinks about each and every data point in this set. And to see what our model thinks about the undefined images specifically, let's go ahead and check this box here. Now these are the undefined labels, but our model has run an inference pass on these, and we get to see what our model thinks of each and every image. Now, to select a subset of these and to iterate through a few of these, let's go ahead and use the lasso tool by pressing here or just pressing E on your keyboard. And then by doing that, you can just draw on this cluster over here, and on the left, we can see that we see an iceberg. We see the iceberg class, and the model thinks that these images in the undefined pool are icebergs. Now let's go ahead and iterate through them. Now as you can see, most of them do tend to seem like icebergs. Let's go ahead and first reset the filters by pressing D on the keyboard. Select undefined again. And then let's go ahead and grab a different cluster. Okay, maybe let's go ahead and grab this cluster. Now what is this? Now these seem like forests, and our model confidently thinks that these are. And it's not wrong. Now the question is, what do we do with this information? How do we turn this model feedback into quality labels? Now, before we start, let me give you an analogy. Imagine you are tutoring a student for an exam, but you have a limited number of time and a limited number of practice problems. But which ones do you pick? Now, the first and the most easiest option is the easy problems that the student is already confident about, which build fundamentals. So in our case, that's the images that the model predicts with really high confidence. And to see that, let's go ahead and first of all, let's reset the filters and then select the undefined samples and take the confidence bar and drag it all the way to the right to see really high confident images. Now, on the right hand side in the embedding clusters, you can see that a lot of these were filtered out because these are the images that our model is really confident about. And to investigate those, let's go ahead and again circle over them. And when we see on the left, our model thinks that these are buildings and it's really confident about that. We saw a forest image here, which is fine. 1 or 2 images are fine, but majority of those do seem to be buildings. Now, as these are easy samples, they already solidify what the model knows. But here's the catch. A student who does easy problems always aces the homework but fails in the actual exam. So the second option is hard problems where the student hesitates. Let's go ahead and press D on the keyboard again, and then select the undefined samples. And let's go ahead. And there's a small mechanic that I want to show you, that if you have already selected the lasso tool, you can press space back to go back to the pan tool, and then so on and so forth. So it's easier to move around and then select images. Okay, now let's go ahead and select the undefined samples again. Now to look at the hard samples, we need to just focus on the images which live on the boundaries between clusters. So let's, for example, go ahead and take a look at this specific cluster over here, which is between the sea and the glacier class. And on the left, as you can see, the first image that we see, it does have a water body, but it does have a mountain with some snow. So which class does it belong to? Is it a glacier? Is it a sea? Or is it a mountain? And when we scroll through these, these do have a lot of mixed samples. You don't know which ones they belong to. And these are the hard samples that I was talking to you about. And this is where our model is really underconfident and doesn't understand where to place these images specifically. But if we can teach the model what these are, it becomes very good at judging these scenarios. And that results in a really high score. Now, the third option, and that's the winning one, I would suggest that you focus on both the things and balance both. Add a bit of each class where the model is confident and a few samples from the confused boundaries, as we saw here, and which covers essentially the fundamentals and the edge cases. Now that's how a student stops memorizing and starts recognizing patterns, which is exactly what generalizing within test set means. Now, before we move ahead, I would like to first of all give a final tutor instinct, is that don't just drill algebra and skip geometry, because if you, let's say, label 800 forest images, so forest, for example, is here, and if you, let's say, you label a huge cluster of them, right? So let's say we have 800 and we just label all of them, looking at individually, and we select which ones are forest and we label. Now, what's going to happen is that you have built a forest expert, and now this expert will potentially fail a sixth of this exam. So your per class counts matter, and that's why I recommend that add easy and hard samples of each class in one single pass when you investigate a run, and then create a new table revision and train on it. So I'll show you first of all how to first label a batch of images and then create a table revision and then again retrain on it to see the results. Now let's go ahead and then select a few samples from the undefined pool. Focus on the really high confidence ones here to add a little bit of both. Now let's go ahead, and how many? These are 60 images of forests, and by eyeballing we can clearly see that all of them are correct. And to select all of these samples in a cluster and label them all at once, you just select this tick box over here or press Ctrl and A on your keyboard, the label column, and then you can just select whichever class you think. Left click on the undefined label and then just label whichever one you want. Now what happened here is that all the images that we had selected in this cluster, we labeled all of them forest in one sweep. This is not going to be easy for every class, because especially working on harder samples, you are going to work in clusters where the model is really confused about certain classes, and you have to be very careful about how you label them. And to show that, I'll just quickly go ahead and take a look at this boundary, for example, of the streets and forests. Let's select these subset of samples and make sure that you select the undefined ones, because we don't want to mess up the pre-labeled correct samples. And out of these, for example, you can see that we have a couple of forests, couple of streets, and let's say in this, for example, if we start here, we had a forest over here, and then it went all the way up to here. So what we can do is just select this and then shift and select the last sample that you thought was forest, and then again left click on the label and then treat it as a forest. Now that you have done this for a forest, you have to do it for each and every class. And once you do that, go ahead where it says commit pending edits, write a new name for your table. So let's do version 2 and hit commit. Now, let's go ahead and take a look at the table section. As you can see, version 2 was created, and you can see in its lineage that it was derived from this initial table that was the train set. Now, every edit in 3LC creates a new revision, so nothing is overwritten and your full history is preserved. And this lineage is also how we verify our labeling budget and final evaluation. So for example, after we run training on this script, let's say if we do not get an improvement in our score, how do we fall back in a previous table and then take it from there again? So to do that, first up, let's go ahead and run the training script and see what we get. The train script is designed so that we train on the latest table revision. And in a minute, we will see that our train table now is version 2 and our val table is the same. And if you can see, the initial budget that we had was 600. We added 72 more images. So 60 of the easy samples and 12 of the hard samples of forests. And now we're training. And there it is. We started around 70%, and even after adding perfectly correct labels in one class, the score dropped. The labels were correct, but we still ended up with a worse model. Now, why is that? Because of the unbalanced data. The model got biased towards forests and started predicting them where it should not. And that's exactly what I was talking about, the algebra expert failing the exam. After this run is complete, I'm going to show you how you can fall back to a different table revision in the dashboard itself and then redo your strategy of labeling and then improve your score. Okay, now that the run is complete, now let's head over, and as we can see, we have a new run that has been created, which is worse than a previous run. What we can do is we just go to the previous run that we had created. But there is one important thing here. If you see in the foreign table section, we are on version 2, but we don't want version 2 because the table that was created, which was named version 2, is bad. So what we can do is we can always fall back to the previous table revision by first pressing P on your keyboard, P for parrot, and you come to the details panel. Now here, if you can see, you can select the table that you want. And if, let's say, if you messed up on version 2, you can always click the first initial table, and on the left hand side, you can see that the forests that you had added before do not show here because we are falling back to a different table revision. Now I'll quickly show you, like if you add easy samples of each and every class in balance, the score will go up. And when you add harder samples, it will go up by a larger delta, but that is for you to try out. So let's go ahead and I'll show you quickly how you can get easy wins. Okay, so now that we have added around 50 to 60 samples of each and every class, let's go ahead and then commit our pending edits and let's do a version 3. I hit commit and a new table will be shortly created. And now that it has been created, you can see that the new images have been added, around 50 images per sample. And let's go ahead and run training again. Now that you can see, the labeling budget has been increased. We are at 921 right now. And there you have it. Just by adding 50 images per class, we can already see that we have jumped from 69.5% accuracy to 71.5 accuracy. So that's almost a 2% improvement just by adding 50 of each class. And I have not even added the hard ones yet. I've just added easy ones of each class. And imagine if you were to add the hard samples as well along with those, you would see a bigger improvement. We have seen the whole workflow and how it looks like. Now you have to just keep on looping this over and over again. Label a balanced batch, then retrain and submit. And then once you find your score, then open up a new run, look at what confused the model, and now start labeling again. Ensure that you have a 3000 sample limit. And how many samples you add in one pass is up to you. But again, make sure that you strategize this properly. If you get stuck at any point, any concept, an error or dashboard mechanic that you want to learn, you can potentially ask me on Discord or in the discussions tab on Kaggle. And if that's still confusing for you, I can also do office hours on Discord. And I think that this is pretty much a really good learning experience for everyone. Form a team, up to 4 members, register when we kick off, and start thinking about the strategy earlier, and make sure that you document your progress as you go, because at the deadline, everything goes into your private GitHub repo. And for evaluation, I would need your code, your write-up, your 3LC project, your embedding screenshots, which is also where the best embeddings prize is judged. Before we end the video, let's do a final submission on Kaggle. Our prediction is complete. Now let's go ahead and check the submissions folder. A new submission file is created. Let's head over to the leaderboard. Let's submit a prediction. And let's upload the latest one. This was the score that we previously uploaded on the leaderboard. Now let's uncheck that, assuming that the score that we get is going to be an improved one. And as you can see on the leaderboard, we have gone up by quite a bit on the score that we have received. So our model, just by adding a couple hundred, we literally added around 450 samples, and we got such a huge improvement of more than 5% on the test set. So this is the type of improvement that I expect to see from you guys. Hope that you learn a lot from this competition, and may the best data win. Thank you.